3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
And now another shocking update is on the way. A new signal has emerged that could change everything we thought we knew about this interstellar visitor and the unusual cosmic events surrounding it. Stay tuned as we go deeper into the latest discoveries and unravel the mysteries trailing this silent visitor through our solar system. The gamma-ray burst that shook astronomy. NASA's Fermi Gamma Ray Space Telescope has detected an unprecedented burst of high-energy radiation. And here is the part that has scientists around the world losing sleep. This violent eruption of gamma rays came from the exact same region of sky where 3I Atlas first appeared.
And it's only the third object ever confirmed to have come from interstellar space.
The burst, now officially labeled GRB 250702b, shattered every record in the history of gamma-ray astronomy. It lasted over 7 hours. 7 hours of continuous, pulsing, high-energy radiation streaming across 8 billion light-years of space. To put that in perspective, most gamma-ray bursts last a few seconds. Some stretch to a few minutes. Scientists have observed thousands of these cosmic explosions over the decades. None of them behaved like this one. The burst emerged from a dust-choked galaxy so far away that visible light could not escape. Only the highest energy radiation made it through, suggesting an extraordinarily narrow and focused jet traveling at over 99% the speed of light. That jet was aimed surprisingly close to the plane of our solar system. When researchers compared the sky coordinates, the timing, and the trajectory data, they found something that made their blood run cold. Two independent, extremely rare cosmic events were pointing toward the same neighborhood of the constellation Sagittarius. This is the same region of sky, by the way, that became famous for the 1977 WOW signal, that unexplained radio transmission that has puzzled scientists for nearly 50 years. Public statements from NASA and other space agencies have remained cautious. They emphasize that no physical link has been proven between the gamma-ray burst and 3I Atlas. The distance of 8 billion light-years seems to rule out any direct interaction. But in private conversations, astrophysicists admit that this alignment demands much deeper investigation.
A comet that shouldn't even exist has lost its tail, defied physics, and grown mysteriously brighter when it should have become dull.
Statistically, the probability of such events converging in both time and space is extraordinarily low. Some researchers are calling it the most significant cosmic coincidence ever recorded. And this is just the latest development in a story that keeps getting stranger by the day. To understand why scientists are so concerned, we need to go back to the beginning and trace how this mystery unfolded. The discovery that started it all. It started quietly, the way most universe-changing events do. On July 1st, 2025, astronomers detected an unfamiliar object slipping into our solar system. It was not orbiting the sun. It was not slowing down. Its path made one thing absolutely clear. This object did not belong here. Scientists gave it the name 3I Atlas, marking it as only the third confirmed interstellar visitor ever recorded by humanity. Think about that for a moment.
It turns out that the two directions of the WOW signal and 3I Atlas are aligned.
In all of human history, with all of our telescopes and satellites and space probes, we have only ever confirmed 3 objects that came from another star system. The first was Oumuamua in 2017, that strange, cigar-shaped object that sparked wild speculation about alien spacecraft. The second was Comet Borisov in 2019, which looked more like a traditional comet, but still raised plenty of questions. And now we have 3I Atlas, and it might be the strangest of them all. Less than 24 hours after 3I Atlas was spotted, NASA's Fermi telescope registered that extraordinary gamma-ray burst we just discussed. The timing was remarkable. 2 incredibly rare events, occurring almost simultaneously, coming from the same direction in the sky. Scientists immediately began asking questions that had no easy answers. Was this pure coincidence? Was there some connection they were missing? Or were they looking at something that would force them to rewrite the textbooks? The public disclosure of these findings did not happen immediately. The full details were released only days before 3I Atlas was scheduled to make its closest approach to Earth.
The comet's path will take it past even more of our robotic explorers.
This delay fueled speculation and debate across both scientific communities and social media platforms around the world. Standing alone, none of these facts proved anything dangerous, but together they formed something far more unsettling, a pattern. And just as astronomers turned every available instrument toward this silent visitor, its behavior began to reveal details that no one was prepared to explain. A visitor like no other. Once the initial shock faded, scientists did what they always do. They started measuring everything they could about this strange visitor. 3I Atlas was not just another object drifting through space.
NASA-funded telescopes have their eyes on the sky all the time.
Its path told a clear story. It was moving too fast to be captured by the sun's gravity. Its trajectory was sharply curved, a signature of something born around another star and ejected long before our solar system ever noticed it. Telescopes across the world locked onto the object. Data poured in from optical, infrared, and ultraviolet instruments. At first, 3I Atlas appeared comet-like. It showed a faint coma, which is that fuzzy cloud of gas and dust that forms around a comet's core as sunlight warms its surface. That should have been reassuring. It was not. As 3I Atlas moved closer to the sun, its brightness began to change in ways that made no sense. Instead of steadily increasing as expected, the light fluctuated wildly. It brightened, dimmed, then brightened again without any clear link to distance or solar heating. Standard cometary physics simply could not explain what was happening. Then came the tail. Most comets develop tails that stream away from the sun, pushed outward by solar radiation and charged particles. 3I Atlas displayed something far stranger. Observers noted an antitail, a structure that appeared to point toward the sun rather than away from it. This phenomenon is rare, but not impossible. What troubled researchers was how stable and persistent this antitail remained over weeks of observation. The rotation data added another layer of unease. Typical comets tumble irregularly, spinning faster or slower as jets of gas erupt from their surfaces. 3I Atlas rotated smoothly. Its spin rate remained controlled and consistent, showing none of the chaotic behavior scientists usually expect from a loosely bound icy body flying through space. Harvard astrophysicist Avi Loeb later stated publicly that the object exhibited at least 15 distinct anomalies. Not random quirks, not measurement errors.
Now, the world's most powerful telescopes are hunting for answers to a question that keeps astronomers awake at night.
These were persistent features that remained consistent across multiple observations from different telescopes around the world. Meanwhile, the gamma ray burst itself raised more questions than answers. It originated nearly 8 billion light-years away, inside a dust-choked galaxy where visible light could not escape. Only infrared and high-energy radiation made it through, suggesting an incredibly narrow and powerful jet traveling at nearly the speed of light. That jet pointed in the general direction of our solar system. By this point, scientists were no longer just asking what kind of comet this was. They were asking whether it was a comet at all. Here is where things get really interesting. When the comet started emitting energy. As 3I Atlas moved deeper into the inner solar system, space-based observatories began detecting something that nobody expected. The object was not just reflecting sunlight or releasing gas and dust. It was actively emitting high-energy radiation.
New images show a compact, brilliant object without the signature feature that defines comet.
X-rays. Now, X-ray emissions from comets are not completely unheard of. They can occur when solar wind particles slam into a comet's coma, creating a brief glow of radiation. Scientists have observed this phenomenon before and understand the basic physics behind it. But what they observed with 3I Atlas did not behave like any comet they had ever studied. The emissions were stronger than expected. Much stronger. They were also far more persistent than normal comet interactions would produce, and they appeared earlier in the object's approach than any model predicted they should. ESA's XMM Newton telescope confirmed the signal, marking the first clear X-ray detection ever associated with an interstellar object. That discovery alone made scientific history, but the details of those X-rays raised even more concerns. The emissions showed structure, They came in patterns. There was a rhythm to them that suggested stability rather than turbulence. This was not the messy, random interaction of solar wind hitting an irregular cloud of gas. It looked organized. Researchers attempted to explain the readings through known physics. They tested plasma interaction models.
So a strange voice from deep space, a mysterious object named the 3I Atlas, has just sent a signal aimed directly at planet Earth.
They adjusted solar wind density assumptions. They recalculated coma size and particle flow a dozen different ways. None of it fully fit the data. Even more troubling, the emissions appeared to fluctuate in cycles that did not match solar activity at all. They rose and fell independently, as if driven by something internal to the object rather than external forces from the sun. Then came another surprise. Water jets and strange chemistry. Water is common in comets. Ice warms as it approaches the sun. Vapor escapes. Jets form. This process is well understood and has been observed countless times within our own solar system. When NASA's Swift Observatory detected hydroxyl signatures around 3I Atlas, scientists initially felt a sense of relief. This was familiar territory.
And it's only the third object ever confirmed to have come from interstellar space.
That feeling did not last long. The amount and behavior of the water emissions did not match what the models predicted. The jets were not erupting randomly across the surface like they normally would. They appeared localized, concentrated, and they were repeating in patterns that suggested fixed release points rather than spontaneous cracking of the surface. Even more puzzling was the chemistry mixed into those jets. Carbon dioxide dominated the emissions, which is unusual because you would normally expect water to be the primary component at the distances 3I Atlas was traveling. Carbon monoxide and other volatile compounds also appeared in ratios that did not align with any known formation models. Scientists compared the data to every known class of comet. Long-period comets, short-period comets, even fragments from the distant Oort cloud. None of them provided a clean match. Then there was the temperature problem. Thermal imaging showed that parts of 3I Atlas were cooler than expected while still actively releasing gas. Other regions appeared warmer without showing any corresponding activity. The energy balance did not behave the way simple sublimation physics predicted it should. Its ultraviolet signature added another layer of confusion. Instead of showing a diffuse glow like normal comets,
a comet that shouldn't even exist has lost its tail, defied physics and grown mysteriously brighter when it should have become dull.
The emissions hinted at structured regions, almost compartmentalized. This implied internal organization, rather than a loosely bound mixture of ice and dust. The great scientific debate. This was no longer just a discussion about chemistry or radiation levels. It had become a heated debate about interpretation, scientific caution, and the limits of what we can claim to know for certain.
The comet's path will take it past even more of our robotic explorers.
Inside scientific circles, opinions began to separate along clear lines. One group argued strongly for restraint. They pointed out that interstellar objects come from environments far beyond our observational experience. Different stars mean different chemistry, different radiation histories, different formation processes. To them, 3I Atlas was unusual, certainly, but not impossible. The universe is vast and strange, and we should expect to encounter things that challenge our assumptions. Another group was far less comfortable with easy explanations. Avi Loeb became the most visible voice among those urging deeper scrutiny. He did not claim proof of anything extraordinary. Instead, he focused on the accumulation of evidence. 15 documented anomalies: stable rotation, structured outgassing, persistent energy emissions, survival through stress zones that should have torn a loose, icy object apart. His argument was elegantly simple. When too many independent anomalies stack together, dismissing them individually becomes a form of bias. This stance drew fierce criticism from some quarters. Researchers accused Loeb of inviting wild speculation. Others warned that public discussion could fuel dangerous misunderstanding. NASA and major observatories reiterated multiple times that no evidence of artificial origin had been detected. The official classification of 3I Atlas remained conservative. Yet the language inside technical papers quietly shifted in subtle but noticeable ways. Phrases like not fully constrained and outside standard parameters appeared more frequently. Researchers admitted openly that current models could explain parts of the data, but not all of it simultaneously. The debate spilled beyond academia into the public sphere. Media outlets framed the story as controversy. Social platforms amplified extreme interpretations on both ends of the spectrum. Some voices claimed alien technology. Others dismissed the entire event as overblown coincidence. In the middle sat the data, and the data refused to simplify itself into easy answers. What troubled many scientists most was not any single feature, but the object's remarkable consistency. Natural systems driven by chaotic forces tend to fluctuate. They break. They fail. They surprise in unpredictable ways.
And now, we may even have grounds to suspect that Oumuamua might be connected to the approaching 3I Atlas.
3I Atlas surprised everyone, but it did not break its own pattern. Even critics quietly admitted that something felt off about this visitor. The closest approach. As the closest approach on December 19th drew near, planetary defense teams and astrophysicists alike realized that the stakes were not about impact risk, but about understanding. This was a chance to study a visitor that behaved outside the rules humanity had used to define cosmic phenomena for decades. Every measurement, every anomaly, suggested a story that stretched from billions of light years away to Earth's neighborhood. Research teams coordinated globally. Telescopes in Chile, Hawaii, and Europe captured optical, infrared, and ultraviolet data, while high-energy detectors and radio observatories tracked emissions that defied expectations. Gamma-ray readings from the distant GRB were compared with real-time observations near Earth to look for correlations. Minor fluctuations in the magnetosphere were recorded and cross-checked against cosmic particle flow. No single anomaly was alarming on its own, but the combination of unusual behaviors, high-energy cosmic events, and historical signals in the same region of Sagittarius was extraordinary. Observers marveled at the object's remarkable stability. Its brightness continued to fluctuate in those same odd patterned ways that had defied the predictions of standard cometary physics for months. The anti-tail remained firmly oriented toward the Sun, a persistent anomaly that still had no satisfactory explanation. Jets of gas continued to release material in structured bursts, indicating a level of organization that seemed impossible for a random chunk of interstellar ice. For astronomers and planetary defense teams, it was a moment of incredibly intense observation. Every frame, every measurement, and every spectrum was logged for later analysis. Models were tested, recalculated, and tested again. Nothing fully explained the combination of properties they were seeing. Then came the most unexpected discovery of all. The mystery deepens. Instruments began detecting a faint but persistent trailing signal coming from the object. Unlike the regular emissions they had been tracking for months, this signal carried an unusual signature that did not fit any known natural pattern. It was subtle, almost hidden in the background noise of space.
The most difficult ones to explain are the fact that the trajectory aligns with the ecliptic plane of the planet.
But it was persistent enough to demand serious attention. This trailing signal raised an entirely new set of questions that nobody had anticipated. Was it somehow related to the gamma ray burst GRB 250702b? Was it a remnant of the object's long journey across the galaxy, carrying information about where it came from? Or did it indicate an entirely new phenomenon, something that humans had simply never encountered before in all our years of studying space? Scientists began the painstaking work of isolating the signal, comparing it with all prior data, and assessing every possible explanation they could think of. The characteristics suggested some form of coherence or structure, a feature that had never been recorded in any previous interstellar object. Even as researchers debated what they were seeing, a larger realization began to settle over the scientific community. 3I Atlas was more than just an object passing through space. It had become a key to understanding something greater, something that connected interstellar travel, high-energy bursts, and anomalies that defied all known physics. The implications stretched from the outer limits of astrophysics to questions of cosmic pattern recognition that had never before entered mainstream scientific study. On the final night before closest approach, instruments detected a subtle, sudden spike in emissions from 3I Atlas. The spike was brief but distinct, indicating activity that had not been observed before. This unexpected burst reminded scientists that while the object was passing safely, its behavior continued to defy conventional understanding. Every pulse, every fluctuation was a clue, and the window of observation offered an opportunity that humanity might never see again. So what do we make of all this? 3I Atlas is unlike anything humanity has ever observed. Its stable rotation, structured emissions, unusual chemistry, and strange energy signatures have created a puzzle that our best scientists are still struggling to solve. The gamma-ray burst that arrived at almost the same time, from almost the same direction, adds another layer of mystery that may take decades to fully understand. Some will say this is all just an interesting coincidence, a reminder that the universe is stranger than we imagined. Others will argue that the accumulation of anomalies points towards something we are not yet ready to accept. What we know for certain is that 3I Atlas has changed the way we think about interstellar objects. It has forced scientists to question their models, reconsider their assumptions, and look at the cosmos with fresh eyes. The visitor is now departing our solar system, carrying its secrets back into the vast darkness between stars. But the questions it raised will remain with us for a very long time. Humanity had witnessed a visitor from beyond, and in its passing, the universe had expanded the horizons of knowledge, leaving a legacy of discovery that would shape our understanding for decades to come. What do you think about 3I Atlas and the strange signals it left behind? Drop your thoughts in the comments below. We want to hear your theories.